Hey everyone, welcome back to MLWorks. In this video, we'll be talking about chunking strategies. Chunking is quite the prerequisite for building applications like Rack because Rack requires you to send an input context, which is nothing but the document. And the document is, you cannot pass it the whole document, you have to chunk them and then store it into vector database. So chunking is useful there and it is widely used. There are various strategies that are widely used in building different kind of RAG applications. So we'll be looking at some of the basic and advanced way of performing chunking. So without wasting any more time, let's understand how to perform chunking with Chonkie. So we'll be using the library Chonkie, which is an easy to use lightweight library for only chunking, because it enables you to utilize GPU to load deep learning model for performing chunking with the help of there are like various techniques which requires you to use deep learning models for chunking. So without wasting any more time, right, let's jump in. So first we'll be installing pip install chonkie all, because since we want to perform all these different chunking techniques, we'll install all, and otherwise you have to specifically install other packages like Symantec or OpenAI, Gina, Cohere, Code. Okay, so we'll start with what all, and then we'll install all the packages. So let me run this. So as I said, there are like around 8 to 10 strategies. So first is token chunker. So if you see here, it is quite simple when it comes to this specific library, right? It is quite simple to do chunking because they have same set of methods. You don't have to think a lot about how to set up or do chunking, right? It is same set of methods, same set of parameters that you have to use. So it will be a lot easier when you look at it. So from Chonkie, we'll be importing token chunker, which basically means you'll be splitting the text based on using tokenizer. So here we'll be using GPT-2 tokenizer and the chunk size is 512. By that, what I mean is, consider you have a document with thousands of words. It will split every 512 words and create a separate chunk. So that's what chunk size mean, and there is chunk overlap of 128. So there will be 128 characters, or not characters, words or tokens that will be overlapping between chunks. Okay, that's what chunk overlap means, and we initialize chunker using this method token chunker. So once that is done, we'll be passing a text, which is a single line of text, and then do chunker.chunk on text, and this will give you all the chunks. Now since the chunk size is 512, so when you do chunking, okay, this whole text, the whole sentence, input sentence that we gave, it remains part of only one chunk, which is this one. And the token count is 13 and the start index is 0 and ends at 62, which is the start index for the chunk. Okay, so if you have multiple chunks, you will have different start and end index. This is for passing single input query or single input sentence. But if you have multiple documents, you can take it as a list of documents. For instance, you can use batch chunking, where you pass in different set of documents and then you can do chunk batch. Once that is done, you will get a list of chunks, document chunks. So we'll have to iterate through each document first and then pick the chunk from each document. So this is one way of handling multiple documents simultaneously using batch chunking. So this is also, let me move here. So this is batch chunking, and this is, if you don't want to initialize anything like chunk batch or chunk, right? You can directly pass your sentence, or you can directly pass your list of documents. You can do that as well instead of making like chunk batch or chunking just chunk. Okay, so this is another way of making it callable for chunker. Now what we have seen is just a very basic chunker till now. Okay, now comes the sentence chunker. As the name suggests, it will try to chunk the text based on sentences. So because it will have something called as delimiter under the hood, the sentence chunker, it will look for if there is a full stop or an exclamatory mark or question mark. Okay, it will turn that into a sentence, and try to split the text into sentences. So here also we'll initialize chunker and we pass in GPT-2 tokenizer, and then we have chunk size of 512 and the chunk overlap of 128, which we discussed earlier, and there will be minimum 1 sentences per chunk. Okay, this is how we initialize sentence chunker. And then as usual, what we saw earlier, chunker.chunk, you pass in your input text and this will try to split it in terms of sentences. Okay, now what I'll show is, this is around, there are multiple sentences we have and the chunk size is 512. Okay, based on this chunk size we can directly take this as output, but since we are using sentence chunker, it will try to split these text into 3 different chunks. I hope so it will do that. Let me run this. Before I run this, I have to run this one as well. We have to initialize sentence chunker. So yeah, so what it has done is, it has given, there are 3 sentences and the chunk text, it has given the whole chunk, all 3 considered as one chunk, and token count is 25. Now instead of 512, if I give it as 15, okay, so let me rerun this one. Okay, yeah, that is there, like 2, overlap of 2. Let me run this and then run this again. So if you see here now, after I gave chunk size as 15, it has turned the sentence or chunk text. First chunk is this one, which is split in between third sentence and second sentence, and that will become part of one chunk. Okay, and the token size is 13 and the number of sentences are 2. And the second chunk, this is the second chunk, and the token is 12 and the number of sentences are 1. This is how you can use sentence chunking for splitting your document or anything. So this is basically when you have proper sentences or you have books. Okay, in such scenarios you can use this kind of chunking. And then comes the recursive chunker. As it name suggests, it will try to recursively apply the chunking technique in your documents. So recursively chunks documents into smaller chunks. Good choice for documents that are long, well structured, a book or a research paper. So under the hood, okay, recursive chunker uses something called as recursive rules. Okay, it is mentioned here, and the recursive rules can be, you want to split the sentence or split the document based on certain criteria. That could be full stop, or if you want to split it based on semicolon. Okay, so those are kind of different rules that you can use and perform chunking. So here we are initializing recursive chunking, and here we pass GPT-2 the default tokenizer. The chunk size is 12 and the rules are default rules, we are picking it up, and then minimum characters per chunk is 24 and return times is chunk. So let me run this. So here if you see what we are doing, right? So if you have an input document which is marked down, you can use certain kind of recursive rules. Okay, so when you say from recipe markdown, it means it has to chunk the text based on the rules which are created for markdown. Similarly, based on certain languages, you can have different kind of chunking or splitting of text. So you can do that as well. So I won't run this because we'll do the simple chunking with recursive. So first let me run this one. So not, let me, okay, yeah, this is done, right? This is done. So we initialize recursive chunker here. So then we do chunker.chunk and then text of text that we pass here, and then we get our output, which is chunk text is, this is the first sentence, this is 7. Second sentence, token number, total number of tokens are 8. Then third sentence, which is token number is 12, total token numbers. So this is how recursive chunking will happen. And then this is for when you're passing a single text. You can also pass batch base, and here we are passing the batch, and then we do recursive chunking. So let me run this one as well. So here if I go, then you will see till here, this is for the first document, this is the chunk. Okay, this is for the second document, these are the chunks. Okay, so these are very pretty simple chunking strategies where you don't have to think much. It are like basic rules, it will apply and try to split the sentences or documents or text. Now what we'll do is we'll go back to advanced chunking, where we'll be talking about code chunker or semantic or late or neural chunker. So this is also quite simple. What it will do is we'll initialize the code chunker and we pass in the Python program, whatever the language that you are trying to chunk. Either it could be Java or Python or any other language. And then you pass in GPT-2 tokenizer, the chunk size is 120, include nodes false. So under the hood, code chunker, what it does is it tries to understand the hierarchical structure of your code. Once it understands that, it will try to split that code into various trees kind of thing, like it has nodes and it will have leaf nodes, those kind of stuff. It's basically an abstract syntax tree. Okay, and it will try to segregate the chunks in such a way that it creates a contextually relevant segments. Okay, so this is where we initialize the code chunker and then we pass in our code here, and I think we have kept it as chunk size is 120. Let's see. So let me run it. There is no chunker is initialized. Let me run this one again. So chunker is imported and then yeah. So here if you see, we had chunk size of 120, though it split at token number 42, total number of tokens is 42 until here. This will be taken as one chunk. And then whatever inside this specific with context manager, it is taken as separate chunk. Now if you see, it is 112 because the whole thing, right, it is well beyond 120 token size. Okay, if you pass in around maybe 200, right, I think it will be coming under totally 200 or 250. Okay, let me run this. Yeah, so you will see this is coming under, this whole thing coming under one chunk. Okay, and which is 222, and something outside of it, right, which is something different. Okay, this is the log model part, this is coming under another chunk. Okay, it is able to segment the code to be appropriate. Okay, so that's the whole point of code chunker. And next we'll talk about semantic chunking, which is basically understanding the context of your documents and then splitting the text. Okay, such that you have content which are like related to each other. They are in part of the same chunk. Okay, so if you see here the definition, semantic chunker splits the text into chunks based on semantic similarity, meaning the related content stays together in the same chunk. This approach is particularly useful for RAG applications where context preservation is crucial. So it understands the context of your document, and wherever the document has something relevant parts, they will be taken as part of one chunk. So here what we'll do is we'll import semantic chunker and load the embedding model, such that what will it, in the backend it will try to create embeddings and try to find the similarity between them. Okay, and the similarity should be, there should be some certain threshold at which it has to match, which is 0.5 here, and the chunk size is 20, and the minimum there will be 1 sentences in each chunk. So let me run this one and let us run this as well. So this is where the semantic chunker was initialized, then we do chunk and then we iterate through all the chunks. So if you see here, the text was first paragraph about donkeys, why donkeys are colored black and white. This paragraph is about pigs, and pigs are pink and have curly tails. Now here if you see the first chunk, it talks about donkeys and it exactly segregated that topic outside as one chunk, and when it comes to pig, it took it as a separate topic or a separate chunk. Okay, so there are like number of total 2 sentences. So it understood the context or the content and tried to segregate them based on it. Next we'll look at an improved version of semantic chunking, which is SDPM chunker, which will split the text using semantic double pass merging for improved context preservation. Okay, so what it means, right, let's break it down. So it groups the content by semantic similarity and then merges the similar groups within a skip window. So it will try to find similar groups and try to merge them, and the content where it is irrelevant or the content is not related, so it can be skipped. Okay, so that's the whole idea behind this kind of a chunker, and this technique is particularly useful for documents with recurring themes. For instance, if you have certain topics or multiple characters in a book, okay, so there will be in chapter 1 he's been discussed, and then chapter 2 is skipped, again he comes back in chapter 3. Okay, there are certain, so the particular character's context is present across multiple chapters with certain pages which there is no any relevancy for that specific character. So there is certain recurring themes across or spread across the document. So we try to understand that and try to create a chunk based on it. Okay, so when it comes to implementation, we just have to import SDPM chunker, and the model for this is portion based 8 million parameter model, and the threshold is, again you have to use a similarity matching you have to do, and there is a threshold you have to set. What is the chunk size, what is the minimum sentence that you should have in one chunk, and what is the skip window, number of chunks to skip when looking for similarities. So that's what one chapter 1 and chapter 3, and then number of chunks you have to skip in between, whatever it is that you can view a skip window. So once a chunker is initialized, then what we do is we have our text which will be sent to the chunker.chunk, and then we'll create our chunks, and then we'll be getting our chunked text outside. Okay, let me run this. So here if you see, we have neural network process input data through layers, and this is part of one chunk, and total number of token is 2 and sentence is 2. Then this GPU related stuff, it comes under another chunk. Okay, and this is 2 again, sentence 2. So what is the total chunk size? Okay, so it is 50 chunk size. Though it is 50 chunk size, it is able to segregate based on certain kind of a topic. Okay, this is about training or training data or kind of a neural network. This is about GPU. Okay, so somehow it has managed to create the chunks based on that understanding. Okay, now when it comes to late chunker, so we have to understand this is similar to something like recursive chunker. Let's understand that first. So instead of generating the embeddings for each chunk independently, so basically what happens in traditional chunking will be creating text, will be splitting the text, and then we'll be performing embeddings. Okay, now what he'll do here is we'll be generating the embeddings first, and then we'll perform chunking. Okay, it then splits the text using recursive rules and derives each chunk's embedding by averaging the relevant parts of the full document embedding. Okay, so once you have split the text, then you perform you don't even split the text first, you first perform embedding, and once the embedding is generated, you will be trying to split the text using recursive rules which we discussed earlier. Okay, and this will try to average relevant parts. So you will be having certain documents present across first chapter, third chapter, you will be trying to average those and then create your final chunk. So this allows each chunk to carry broader contextual information, improving their retrieval performance in RAG system. So this requires us to install a certain variation of NumPy and Keras. So we install that, and then we import late chunker, and we use the sentence transformers model called all mini lm L6v2, and the chunk size is 10, and the recursive rules and min character per chunk is 24. So once this is done, we'll be just applying the chunker on top of the text and get the chunks out. So let me run this. Yep. So what is the chunk? That is 10. Okay, I think it is taking the previous one. So let me run this again. So the chunker is initialized here, and then here we are trying to chunk the text. So this is taking time because we are loading this model, and if you have GPU, you can mention that also. You have to give CPU or CUDA, then you can load the model. So while that is happening, let us jump to neural chunker. So this will be using something called as fine-tuned BERT to detect the semantic shifts. So it leverages that power of deep learning. It uses fine-tuned BERT specifically trained to find semantic shifts within the text, allowing it to split documents at points where the topic or context changes significantly. So consider, right, you have a storybook, okay, where are like separate small short stories each chapter. Now there will be one kind of a chunk for one story, which is a short story, first short story, and the separate chunk for the second story, because it has to, there will be a dramatic shift in terms of stories once you have these small short stories in each chapter. Okay, so at that point in time you can use this fine-tuned BERT model to detect this semantic shift in terms of the document or the text. So here what we do is, again, we import the neural chunker and then the corresponding model that is trained for this, and then map the device, which is CUDA since we have GPU, and then we have minimum character per chunk is 10 and the return type is chunk. Okay, let me run this. This may again take time because it has to load this model. Okay, let's go back to this one where we got our first chunk, token 8, second paragraph continuing with the same topic. Token numbers, total token is 7. So there are totally 4 chunks in the previous one, which was late chunker. Okay, now let us look into this one where we loaded this model, Chonkie modern BERT based one, which is trained for the specific purpose of understanding the semantic shifts within the text. So once it has been object is created, chunker object is created, we have something called as the specific text. Okay, if you see here in this input query, what we pass is, we pass 4 different topics. Limited context window, then it explains what it means, and then there is computational efficiency, then it explains what it is, then better representation as separate topic, and then reduced hallucination as a separate topic. These are the 4 different topics that it talks about, the whole text. So now what we do is, we pass this input to the chunker, which is the neural chunker, and then we get our text, chunk text. So if you see here, let me run it again. So we have used, here we used CUDA because we have GPU, so that is there. Now when it comes to this one, okay, neural chunker, you will see that it has able to understand these 4 different topics and created 4 different chunks. So from first chunk contains 48 token, it starting index is 0 and ending index is 213. And then there is second chunk, which is computational efficiency. It takes the starting index 213 and ends at 445, and it has total of 51 tokens. So it has able to understand that there are 4 topics and it has to split those 4 topics into 4 different chunks, because that is the semantic shift that is happening between the topics. Okay, so with this we were able to understand there are various ways to chunk the text, especially when you have to build a system which is able to understand semantic of the text. Okay, then you have to ensure that you use chunker which are capable of managing the semantic nature of the text. Okay, so with that I'll be concluding this video. Thank you for watching.